Good morning. My name is Aspen Navarro. I am the Watershed Services Program Coordinator at the Meadows Center for Water and the Environment located in San Marcos, Texas. Today I'll be demonstrating our training tools for riparian evaluation monitoring and how we utilize Texas Stream Team citizen science to evaluate riparian health. Key takeaways for today include demonstrating how Texas Stream Team certified citizen scientists evaluate riparian health using a riparian Bullseye evaluation tool. Quality control protocols established to ensure consistent quality data is submitted by citizen scientists. And I will leave you with current monitoring and data limitations in place we are working on with future considerations and research we are brainstorming. This not only helps with research purposes, but also allows us to continue expanding the data being collected. Texas Stream Team is a statewide citizen science water quality monitoring program that operates through a network of trained citizen scientists and supportive partners administered through a cooperative partnership between the United States Environmental Protection Agency, the Texas Commission on Environmental Quality, and the Meadows Center for Water and the Environment, located at Texas State University. Texas Stream Team receives partial funding from the U.S. Environmental Protection Agency through a 319 Clean Water Act grant disseminated from the Texas Commission on Environmental Quality. Texas Stream Team offers several different trainings, but the riparian evaluation training specifically was developed through a collaboration with the Nueces River Authority. Since 1991, we have trained over 11,000 citizen scientists and have monitored at over 400 sites in the state of Texas. All in all, we have established over 100 partnerships with local governments, organizations, universities, and more. Texas Stream Team Riparian Evaluation training enables individuals to become certified citizen scientists and qualifies them to begin contributing riparian evaluation monitoring data to the Waterways database. The training has 3 phases and is completed within 4 to 6 hours. We offer this training in person and online. Phase 1 consists primarily of lecture to introduce Texas Stream Team, riparian and watershed processes, and an overview of the riparian Bullseye evaluation tool used to evaluate riparian health. Certified trainers describe the use of the Bullseye evaluation tool at a monitoring site, also in Phase 1. Phase 2 consists of side-by-side riparian evaluation monitoring at a different site by both the trainee and the trainers. Trainees are encouraged to take the initiative while trainers observe and provide guidance when needed. Phase 3 consists of riparian evaluation monitoring conducted by trainees at a third site without guidance from the trainer. The riparian evaluation training is based on the 3rd edition of the Your Remarkable Riparian Field Guide book set, which was created by the Nueces River Authority. This field guide includes riparian plants found within most of Texas and is a great resource for background information on riparian functions, values, and plant identification. The book set comes with an owner's manual, which consists of information on managing riparian areas in Texas. It is also accompanied by a pocket guide designed to troubleshoot invasive plants with information about identifying common invasive plants and why and how to manage them. The book set is designed to cultivate awareness and appreciation for riparian plants and the role they play in the production of abundant clean water. The Bullseye evaluation tool is an effective approach to evaluating riparian health. Using the riparian Bullseye evaluation allows you to train your eye to see riparian areas for their function and to identify activities that may be hindering the natural riparian recovery process. The 10 indicators that are evaluated using this tool are active floodplain, energy dissipation, new plant colonization, stabilizing vegetation, age diversity, species diversity, plant vigor, water storage, bank or channel erosion, and sediment deposition. The riparian evaluation tool can be used to monitor the left bank only, the right bank only, or both sides of the water body. However, please note indicators 1, 2, 3, 9, and 10 will always require both banks to be evaluated, as these indicators are channel specific and have to do with the flow and sediment deposition. There are 3 zones on the Bullseye evaluation tool used to score each indicator. The outer zone, which is highlighted on this slide, represents poor dysfunctional conditions. The middle zone represents an at-risk condition or a riparian health danger zone. And the Bullseye zone is in the center of the target and it represents high functional conditions. For the sake of time, I won't go over each specific indicator, but I do want to provide a brief example of how the Bullseye evaluation tool is used to evaluate riparian health. I will use the first indicator, active floodplain, as an example. For active floodplain, citizen scientists are looking to determine if floodwater has access to the floodplain. First, we discuss the importance of each indicator, and then we provide specific key details to look for. These tips help train citizen scientists' eyes on key details that are important for properly evaluating each indicator. For virtual trainings, we begin by showing a 360-degree slow motion video of the site we will be evaluating, and then we display photos of each indicator. For active floodplain, we show photos of both banks, and this slide is a condensed version of the type of photos used for this indicator, which focuses on displaying the left and the right banks. This is the Blanco River in Blanco, Texas. So here we have the left bank on the left side of the slide and the right bank on the right side. Once the photos have been observed and discussed, we present this matrix and ask the trainees to determine which zone best represents the riparian monitoring site. For this site, we selected the mid-zone. Although hard to see in the few photo examples I provided, the right bank isn't steep, whereas the left bank is. Taking both sides into account, this site is a mid-zone for active floodplain. A similar process occurs for each indicator at 3 different sites during each training phase. Citizen scientists document their monitoring data on a riparian environmental monitoring form, pictured here. The left image is the first page, and the right is the second page, which should look familiar from our previous slide. The first page is where the citizen scientist information, data, and signature will be documented. On the first page, the bank that is being evaluated is marked, and the plant species found can be written in the comments section. This information is very important as it serves as a historical record or inventory of the site. The second page is a riparian field quality control checklist. Citizen scientists reference this checklist while in the field to ensure each indicator is completed correctly. Certified citizen scientists submit this form to Texas Stream Team after each riparian evaluation monitoring event, along with 1 to 4 georeferenced photos of their site. Photos are submitted each time a monitoring event is conducted and are used to track changes at a site over time. It is important that photos are taken each time at the same location with the same orientation. Monitoring conducted under the Texas Stream Team program is documented in a TCEQ-approved Quality Assurance Project Plan, also known as a QAP. Monitoring techniques are standardized statewide to ensure consistent data quality. Given the regulatory implications associated with the use of water quality data, the TCEQ uses scientifically rigorous and consistent water quality sampling methods to help ensure valid outcomes. Citizen scientists must complete the one-time training and be at least 14 years of age or in the 9th grade to become a certified monitor of riparian health under the Texas Stream Team program. The monitoring frequency for the riparian evaluation training is a little different than our other trainings. Trained citizen scientists monitor the riparian site 1 to 2 times a year. However, monitoring more is always acceptable. The most important thing to note with monitoring frequency is to make sure the frequency occurs at the same time or the same season each year. Riparian areas, as we all know, are slow growing, which is why annual or biannual monitoring is recommended to capture changes over time. Citizen scientists must monitor at monitoring sites approved by Texas Stream Team staff. A map of active and inactive monitoring sites is available for citizen scientists to look through, which contains site IDs and site names. However, if there are no existing sites in an area of interest, citizen scientists can submit a form to request a new monitoring site be created. This form gets submitted, reviewed, and approved before a site ID is assigned and monitoring data can be submitted. The quality control checklist should be reviewed during the monitoring event and completed. If the quality control field checklist is not completed for all indicators, it will be assumed that it was not adhered to and the data will be flagged in our database. And lastly, data submitted by citizen scientists to the Waterways database are reviewed by a group data coordinator and Texas Stream Team staff to ensure accuracy. The virtual riparian evaluation training is one of our newer online trainings, so we are still working through some kinks, and here are a few. The riparian evaluation training does not apply to all water bodies. Although riparian habitats can be found in coastal tidally influenced waters, Coastal marshes have different vegetative species, are tidally influenced with differing hydrodynamics, and cannot be monitored using the Bullseye evaluation approach. However, our goal is to expand the Your Remarkable Riparian Field Guide bookset to include coastal marsh vegetation and information pertinent to those habitats, so we can include Texas coastal marshes in future trainings. Creation of an index to assist with the interpretation of the data, such as what the number of bullseyes mean, is also another area that is lacking definition. Our intent is to create an index with citizen scientist data in the future, and this type of information will help identify and prioritize habitat restoration projects to improve water quality. And lastly, quality control field audits are required for our other trainings, and we are working to develop similar protocols for our repair and evaluation training. Field audits occur every 2 years to ensure trained citizen scientists are adhering to approved protocols, clear up any questions that may arise, and to introduce new quality control protocols as they become available. Currently, we are working on making the field audits for this training something that can be completed via an online module. All right, and this is all I have for you today. Here's my contact information. If you have any questions, please do not hesitate to reach out, and thank you so much for your time.